I do not believe it's acceptable for any organisation or profession to think that this is an issue that can be parked to one side.
Everything that's happening is happening faster than it's ever happened before.
We're getting questions asked by our supply chain, by our customers.
What are you doing? Can you do more to reduce carbon, to make it more climate resilient?
Are we acting as quickly as we now need to do?
You know what? Climate change is not waiting for COP, it's not waiting for the civil engineers.
This is not some environmental thing that's happening over here.
What you're gambling with is not just infrastructure and assets. You're gambling with people's lives.
I don't want to put the blame on, in this case, civil engineers, but I would put the responsibility of them. They do have the power on designing the infrastructure in a way that will provide all of the solutions.
For some, it's been genuinely shocking to realise that around 70% of the world's carbon dioxide emissions can be traced back to infrastructure. That's when you add up the way that we plan, the way we design, our build processes, but also the fact that infrastructure very often is the cause and the enabler of long-run behaviours that are hardwired to carbon. And this is difficult to shift. And yet this shift really matters because those same carbon dioxide emissions are the primary driver of climate change in the world today. Our response to climate change from now needs to fall into two camps. First, we need to attack the issue, cutting carbon where we can and increasing the world's ability to take carbon out of the atmosphere. This is the key to net zero carbon. Second, we need to defend ourselves. We know we have decades of a worsening climate ahead of us. Creating resilience to these changes will be key. Having listened to so many of you over the past few months, it's obvious that a few really big, challenging questions keep on coming up. And it's really important that we answer these questions if we're going to turn this talk into action. Infrastructure. Is it more important to change how we plan and build it, or better to focus on how we use it? One of the big questions is, which matters more? The way we build things, or the way we go on to use them? And the truth is that both are critical. There is a growing awareness of the difference between the embodied emissions when we create a new piece of infrastructure, sometimes called capital carbon, and then the emissions generated as we go on to use that infrastructure every day, known as operational carbon. In the industrialised world, the operational carbon in any given day, week or year is much larger than the capital carbon. And of course, this is bound to be true, because in places like this, we already have thousands of major infrastructure systems out there emitting carbon all the time. And that's why we must use our engineering influence not only to cut the capital carbon, but also to change the way these systems actually work. I'm not saying we can't build, but we must break the link between infrastructure and carbon. That's easy to say, but sometimes very hard to do. And we have to realise that our decisions not only lock in the capital carbon emissions, but also affect how people go on to use that infrastructure for generations to come. So whether we build, where we build, what we build, all make a significant difference here. I sit on some of the investment boards, and so when projects come that will last for 80 years and they haven't thought how it's going to be operated and decommissioned, I can really challenge, and they don't get the approval to go forward to the next stage.
One of my favourite phrases is we build it once and we operate it forever. And so when we're trying to make those evaluations, answer those questions of what to do, we've got to always look at that very long-term thing, because what we decide now makes huge differences over the long term in the life of the projects.
So much of what we need to respond to comes from what's already here.
If we're going to build corridors from Kenya all the way from East Africa to West Africa to South Africa and call them smart infrastructure, we need to start at zero and we need to collaborate urgently across this country.
The change that we've seen in our climate is in large part due to the choices that we've made on infrastructure over the last 30, 40, 50 years especially. And it follows therefore that the change that we need to see in the future, the challenge of addressing climate change, is largely about the infrastructure choices that we will make.
So why aren't we talking more about concrete and steel? This year, we'll pour 3 tons of concrete for every person alive on the planet today. And that has a carbon cost. Concrete and cement production are responsible for 8% of global emissions today. And similarly, steel, another 8% of our global emissions.
We used 90 million tonnes of concrete in the UK alone. And you look at it in a global context, it's colossal. And it's a solvable problem. It hasn't got to be this way. And so what would be a frustration would be if we didn't make the effort to do something about it quickly.
So we know from our work that a big part of our footprint is linked to concrete. So absolutely core to the projects of the future, the flood projects of the future, are how we reduce the carbon content in concrete.
It's really important to think about the materials that we use, and I think often we have not been thinking about that as one of the key challenges here. And again, this is another area where there is a huge opportunity to act and to change.
Without the joint effort of professions like civil engineers coming on board in enormous numbers to help us, we're never going to get there.
Everyone has to pull on the same rope. You know, we cannot expect that the supply chain will deal with it on their own, or contractors will deal with it on their own, or engineers will deal with it on their own, designers or specifiers. We need to get to an environment where it's an approving environment with caution. How do we make it happen quickly, not in the usual 10-year cycle? We need to get to a much quicker place.
There is good news here. Innovation is bubbling around new, lower carbon methods and materials. We're starting to find ways to make more of the infrastructure we already have. And there are good efforts emerging to reduce quantities and waste. But there's much more to do. We also know that we need to get ready to deal with a worsening climate as we look ahead. So at the same time as we bring down the capital and operational carbon emissions, we must also think about how to make our infrastructure investment more resilient and adaptable to climate conditions that we've not yet experienced and which are changing fast. With so many different concepts flying around to do with climate and carbon, it's probably helpful to try to show how some of them can come together in one project. Just behind me here is part of the Kent coastline. It's the Hythe Ranges scheme. Now, this is one of the first of its kind in the UK to combine together both climate resilience through its very nature, it is a coastal defence scheme, but also climate mitigation because it's been constructed in part from low carbon concrete.
Civil engineers have a huge role to play in designing in, engineering into the projects that are being developed right now, low carbon and resilient solutions. So one great example we've been working on at the Environment Agency are the new sea defences at Hythe. We took a risk in that project, knowing that we needed to reduce our emissions.
Infrastructure will have a climate impact for some time to come. So what can we do to put this right in the meantime? We don't know how to build without carbon. And we don't know how to run an infrastructure system with zero impact. And we have an even bigger problem because we've already got far too much carbon dioxide up there in our atmosphere. So I hope you'll agree that if we all want to get to a better place, we need to talk about offsets. But what does that actually mean? So what are we going to do with this leftover carbon once we've brought it down as far as possible? Tim?
One of the really good things is geosequestration, which is basically just putting the carbon underground and storing it there. It's a really inexpensive method that we can roll out today.
One point I was thinking was fuel cells, specifically molten carbonate fuel cells.
We could invest in biodigesters. We could not only save carbon, but it also helps develop the community by improving their health, by reducing particulate emission.
So mangroves are forests between the land and the sea, And not only can they store 40 times more carbon than rainforests, they also stabilise coastlines and provide food security.
So worldwide, peatlands capture more CO2 than any other type of vegetation.
Planting trees in an area that has suffered from deforestation.
Utilise natural systems to store CO2 emissions and send them to the ocean floor, keep them away from our atmosphere.
It's one of those solutions that's really, it's not an overnight process. It's something where we're definitely going to have to work on this continuously for years to come.
We need to consider the financial returns. As for investor, their money is the key, and for ensuring they get better returns, the green project needs to be more attractive from their perspective as well.
If you're planning to plant a tree to make up for that emission that you are causing through activity X, then that removes the ability to plant that tree for something else later. So the planting of trees, for example, is something that really we can't just rely on any longer.
But how long does a tree take to grow to actually capture the carbon from the atmosphere? You know, we're talking about 10, 15, 20 years, while within 2 years of design work, you can actually design out the carbon.
When it comes to considering whether it's offset or nature-based solutions, we have to do both. Nothing can replace and must replace the trajectory of reducing your emissions.
This is about technologies that can reduce emissions by capturing, reusing and storing carbon. Also about nature-based solutions where we look with fresh eyes and recognise the potential of our land and oceans to do more. Sometimes we can build in direct offsets to projects and investments. Other times it will be a commitment to create an offset elsewhere. Either way, we need to start to weave this into our engineering thinking from now.
So what happens if we don't act fast enough? The truth is that nobody really knows. We have no models that can predict the impact of the breakdown of systems at the level of the whole planet. But one thing is clear, those impacts will be unmissable.
What happens if we don't act fast enough? Africa thinks we have problems. We will have major problems.
All of the nasty things that are happening now will be happening twice as badly next year and twice as badly again the year after. I think what's infuriating is not the sense that people think it's too difficult, but people don't even sense that there's a problem at all.
We all think we've got time in order to do this, and actually we don't. The information we're seeing from the Government Department of Bays is saying that we absolutely have to act now.
I mean, in January last year, we had the worst air quality of any city around the world on that day as a result of bushfires that were hundreds of kilometres away that still impact city. I mean, imagine what it was like for them at ground zero.
So we need to turn all this talk to action. And to do that, we each need to understand what good climate action really looks like. Well, it means moving at pace in the right direction, where that direction matters more than perfection. Small steps every day are what will count here. We've got to get comfortable with the idea that we won't have all the answers, but that is no reason to delay.
The implications of not acting fast enough are dire.
None of us would love to or would like to live in a world increasing the temperature 2 degrees or more. Science is already showing us, and nature is showing us, the level of impact and the level of suffering that we will have worldwide. It's unacceptable.
Well, I think what's required is a really fundamental transformation in the way that civil and infrastructure engineers do their work. And it's got to happen now, because the carbon that we put up today has a compounding effect. It means it's much more significant than the carbon in 20 years' time. We've just got to stop wasting stuff. We've got to pick the right projects, and we need to get on with it.
Civil engineers, we have the power to make a serious difference here. But that means we need to act at speed, and we need to bring our very best problem-solving skills to work. This is being recognised all over the world. This risk is growing. Last time, I asked you what you were going to do. This time, I'd like to ask, what's stopping you?
with it.